This will be a showcase of the success of the deliverables in this project and how they meet the outcomes. Overall, this project has been successful as it meets its functional and non-functional requirements. More details of the creation and testing of these deliverables can be found in the research section and the test plan. Here you can see footage of the automated charging. The outcome for this deliverable is to be able to switch between flight mode and charging mode automatically. First, you can see the use of buttons, successfully testing switching between flight mode and charging modes. An issue with this is it wouldn't switch all the time and it cannot be automated. Next, a better switch was used with updated and more efficient code for accurate switching. While successful, this also cannot be automated. Finally, coding using Flask and Waitress on the Raspberry Pi allowed automated mode switching using HTTP requests using Postman. This successfully completes this deliverable of automating charging, as now the simulator can send a HTTP request to the drone to switch charging modes when the drone is low on charge and on the wireless charging pad. The next deliverable is research into wireless charging. The deliverable of research into wireless charging was exceeded, as alongside documentation research in the research and findings section, a functional prototype was also produced. Here you can see wireless charging tests being successful and the wireless charging producing an output. From here, calculations were made about how this wireless charging can be upscaled to charge the drone. More specific details into the outcomes of research into wireless charging are shown in research and findings and the outcomes below. The deliverable of image recognition was achieved through successful recognition of a helicopter pad. This provides tangible evidence for an automated drone being able to land accurately, meeting KPIs of increased landing accuracy of the drone. This process was completed using OpenCV, an image recognition and computer vision library, and the Python programming language. The next section showcases the automated flight deliverable of this project. This is shown as the drone has been uploaded with a flight plan by configuring its flight controller to take instructions using the simulation software Q Ground Control and PX4. Then the flight path is set up using Q Ground Control. After this, the program is run on Q Ground Control, starting the flight plan and flying the drone. Here is the simulation view. As you can see, the flight plan was configured and is followed by the drone. Using the simulation software Gazebo, a digital copy of the drone called a digital twin could accurately be used to collect realistic results. This is used to produce results for the test cases as beyond the line of sight regulations prevent the drone from being flown outside autonomously. In this simulation, all functionality of the drone is showcased via simulation and produces the results for test cases 1 and 2. In test case 1, the drone flies from a delivery center in Reading to the Newbury post office, taking 2 stops at Vodafone base stations along the way, which were located using CellMapper. From research and calculations, it was discovered using the drone charger it would take 30 minutes to recharge fully, which is taken into account for this flight. The drone would simulate the stops and wireless charging process by landing for 30 minutes before flying to its next planned location. For this simulation, the DJI 900 drone's maximum speed of 16 meters per second was taken into account. However, the assumption was made that the drone would only be able to fly at a speed of 10 meters per second or 36 kilometers per hour. This is because in this scenario, the drone would be loaded with a package and have heavy charging hardware attached. The drone could fly 9 kilometers before having to recharge. Time taken for the journey was 1 hour, 30 minutes and 46 seconds. The full journey included charging stops along the way. This data is presented in results and findings. From here, the drone will fly off and complete its journey. And finally, in test case 2, the drone is flown along Exolum pipeline, stopping at base stations along the way, similar to case 1. However, in this case, the drone flies over 4 hours trying to keep in sight of the pipeline, from Shinfield near Reading to Marlborough. This simulation is compared against helicopter usage instead of item delivery vans. This is because helicopters are the common method used by pipeline companies such as Exolum to monitor pipelines for damage. This provides data for automated drones against helicopter flight. A key point to consider is this is another area that image recognition will be useful for the drone, as it will need to keep track of the pipeline. A higher quality camera would be an advantage for this task, making it easier to keep track of the pipeline located on ground level. This potential advantage for the future is mentioned in more detail in recommendations. The results of this flight are shown in the results and findings case 2 section. Case 2 exceeds the project scope as only one case was requested by stakeholders. This second case provides much more detail into the uses of drone technology and assists in providing a new point of revenue for Vodafone. Case 2 exceeds the project scope as only one case was requested by stakeholders. This second case provides much more detail into the use of automated drone technology and assists in providing a new point of revenue for Vodafone. Some learning gained during this project was learning how to use many different software at high levels such as Python, Gazebo, Q Ground Control, OpenCV, and many others mentioned throughout this project. Hardware learning was also undertaken, such as understanding the use of microcontrollers and wireless charging. Teamwork and team management skills were increased, and use of project management tools such as version control software such as GitHub resulted in learning that can be taken into a future project. Other deliverables such as test plans are located in the appendices and document more detail into the inner workings of the project. Circuit diagrams were created which are shown in research and findings. However, they weren't as necessary in this project as the team could communicate ideas vocally over the Teams meetings. Outcomes of project management and other related documents are located in the write-up below. Overall, as can be seen in this video, the project was a success and exceeded expectations in many areas. Thanks for listening.